All right, welcome back. We're going to talk about the slope of a tangent line now, and it'll also involve the notion of the limit again. All right, so first of all, if you have a function f and you look at its graph, this is called the secant line. If you take 2 points, connect them, that line there is called the secant line. Okay, and its slope is just, the change in f all over the change in x. So what that means precisely is f at b minus f at a all over b minus a. Okay, what we want to know about is not the slope of the secant line, because that's easy to do, but if you were just at a, what is the slope of the actual tangent line? And it's not obvious yet how to do the slope. But now that we've seen what we did with instantaneous velocity, we're going to try the same trick, that we can approximate the tangent line with the secant line if we just move over a little bit. And then we can take the limit as that little bit shrinks to 0 and see what that slope is getting close to. So, again, the idea is you take the graph of f here, you grab your point A, and you move over just a tiny bit, a plus h. So h is some tiny number, all right? And then you draw the secant line here, and you calculate its slope. So that'll be f at a plus h minus f at a all over h. And you figure that as h goes to 0, you figure that this slope will converge to the tangent line slope. Okay, so remember, that's the process of taking a limit. So here's what we've come up with, that the slope of the tangent line to the function f at x equals to a ought to be the limit as h goes to 0 of that secant line slope. So that was f of a plus h minus f of a all over h. Remember, that's what we had up here, right? Okay. All right, so limit means, again, you let h head towards 0, and then you look at what this quotient is heading towards, and if you can figure out what it's heading towards, that'll be the limit. All right. Let's do an example of this, because in practice, with some of these straightforward examples, you can really see the answer just by looking at it. So find the slope of the tangent line to the function f of x equals x plus x squared at x is equal to 3. Okay? So x plus x squared will be a parabola, and, well, anyway, it doesn't even matter. So here's the answer. The slope of the tangent line at x equals to 3, we said you're supposed to calculate the limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. Okay? Well, that is definitely too complicated to be able to see the answer. So let's plug in some stuff here. The function was x plus x squared, so it'll be 3 plus h plus 3 plus h squared minus 3 plus 3 squared all over h. All right, still too complicated. Let's do some simplification here. So on the top, we'll have 3 plus h plus 9 plus 6h plus h squared minus, I guess, a 12 all over h. Now, this 3 and 9 add up to a 12, so that'll cancel there. So we have 7 h's on the top and an h squared. Still can't see the answer, but I can divide out by the h there. So I'll just be left with 7 plus h. By the way, you notice I've kept writing limit on every line, because until you take the limit, you have to write that you're still supposed to take the limit. So don't skip writing it till you actually take the limit and get the answer. Anyway, the process now was you let h head towards 0 and see what 7 plus h is heading towards. Well, if h is heading to 0, then 7 plus h is obviously heading to 7. So the answer is 7. So the slope of the tangent line is 7. And that's it. All right. Ciao.